I want to kick off with sort of maybe getting everyone to say their thoughts on George's talk, in particular this key question of the matrix between solving problems, doing curiosity research, combination of two, or avoiding that blank down in the corner.
I'm happy to kick it off. And it was interesting when George came back to his seat, I said, oh, George, everything you've said, there's music to my ears, because as probably some of you may know from the research that we do at the Smart Center, it very much fits into the kinds of points that George has raised, which is, if you really understand the context and the problem, and whether that happens to be the environment, which is, in our case, the issue, how do you then define, and in fact you may wish to redefine what some of the new scientific answers and challenges you might be looking for. But I guess from our context, it always starts with that bigger understanding of the context in which we operate. So from my point of view, I can probably relate personally how it all happened. As an academic here at UNSW, I chose to take one of my sabbaticals at a steel plant in the States. I did my PhD in the States, so knew a few people there and said, right, I'm going to go off and do my sabbatical there. And I suppose, for me, the answer was almost like, that thought experiment that said, why are they doing this? This is sort of, a bit, outdated. There are things that they could be doing. And of course, if you ask operators the standard questions, it's pretty obvious that you can understand the world in which they operate. They are limited by the day-to-day practical limitations. So on one hand, it was for me personally about understanding the context, in this particular case, the specific technology, the steelmaking technology. The short answer to all of this was, came back to UNSW, applied for the typical sort of ARC grants, got all that, and I guess, the science, after we had sort of established what that was fabulous. So it's sort of, maybe if we had stopped at the point, like George says, we had just done the science, it would have been a great achievement in its own right. Yes, it won the Eureka Science Prize and all of that. But the nice thing for us was there were enough industries in Australia, and of course one of them, One Steel, has been our long-standing partner who actually has taken on the technology. But that's because we actually had the context of how this technology could deliver the benefit. So it's back to the point that George has raised earlier. I think for all of us, there is the big picture, the world. It's about how we create that opportunity for ourselves, whether it's through our engagement with industry or whoever the end users might be in our particular case. But I think it all has to start with that appreciation of the big picture context. So I can't thank George enough for giving this speech, which I've heard. So
anyone has any thought then how we do this? Peter, you want to?
Oh, just to mention something else. I think you introduced her as a material scientist. We are discussing here the future of chemistry. Is that right?
But I think it's good to have a perspective from the outside, and I think
sure. No, I don't think it's from the outside. Actually, we should be more aggressive in how do we define chemistry. We should not say there's material science, there are the health sciences, etc. I think chemistry today, and that has changed over the last 30 years, is so broad. I consider material science to a very large part as chemistry. I think that's something, whenever you work on materials, you transform matter, and the transformation of matter, that's chemistry. So I think something that has changed and will change further. I can see that also at this conference. I think we had very nice examples of something that at a physical organic chemistry conference we would not have talked about tissue engineering 20 years ago. I think that's something that we see, and I think this will continue, and as chemists we should really be more aggressive on this to define our field, not too narrow. I think that's a point I just thought I'd
make. I absolutely agree with that. I think there's science and then there's non-science, and I think a lot of science is converging to molecular science anyway. Biology is coming down to it, physics is coming up to it, and the only difference is the way they address the problems. And I was actually that was going to be my joke, welcome to finally becoming a chemist. Oh. But actually going back to what George said, I thought I puzzle with some of these questions, or some of these thoughts he puts forward. But another way I wanted to paraphrase it was there's important questions and unimportant questions. The problem is, for me, is working out what are the important questions, the unimportant questions. And I also grapple with, chemists, one of the unique or reasonably unique things about chemistry is we create capabilities in creating new things. And when I look at my wife as a biologist, she addresses everything from a question. I think a lot about capabilities. And it's that marriage between the two, which for me is the elusive thing that I'm always searching for.
Well, thank you very much. I feel as though I've been here before. In the early 2000s, George Whitesides led a review of chemistry for the Funding Council after the Research Excellence Assessment. And he did a wonderful job. I happened to be on the successive panel a few years later to do the same thing. And there was nothing to do because he'd done it all. And I think today he said it all, except that I would add two things. Despite Pasteur's applied nature, he did also say, in the matter of observation, chance favors the prepared mind. And so I would like to add that having that qualification and also the opportunity of doing something in that right Pasteur quadrant that is both fundamental and applied and important, that one allows space for the serendipitous discovery to be exploited. And I think that applies to chemistry as much as to any other discipline, academic discipline.
Peter, you?
Yeah, well, I really liked George's presentation and the simplicity of putting the whole of chemistry into, or any problems in the world, into 4 distinct areas. One area that concerns me about the future, I guess, and was hinted a bit by Les as well, is the education of students in chemistry and where that's heading. We see a lot of students coming in ill prepared these days, and with the STEM agenda by the government, where that's going to be heading, it concerns me a little bit what's going to happen there. And if students are educated well in the secondary system, then that incites this creativity and thinking, and I think we really need to address that somehow in the future.
George, you want to add anything to what you heard here?
I certainly agree with the notion of the prepared mind, and I certainly agree with anything that provides stimulation for curiosity. There is, for those of you who are students, a complement to the Stokes Quadrant. This was invented originally by Pasteur Quadrant by Don Stokes. It's a wonderful book that some of you may have read, whose title I'm always forgetting, The Nature of Scientific Revolutions by Thomas Kuhn. And he makes the following interesting point, that he classifies what scientists do into 2 broad groups. He says there are what he calls puzzles and problems. And puzzles, he says, are what most scientists work on. And puzzle has the characteristic that before you start, you know there's an answer. You more or less know what the answer is. You more or less know how to get there. Nobody cares about the answer, and you do it anyway because it's so fun to do technically. Okay. Then there's another class of problems which is rare, which people address only when they absolutely have to because theory fails and they're forced to do something, otherwise they live in shame. And that has the characteristic that you don't know if there's an answer, you don't know how to get there, you don't know if you get there whether it's going to make any difference and people really care. And that falls in the category of being things like a cure for cancer, in his example, or a quest for world peace. And the characteristic of working in sort of Stokes Quadrant stuff, and again I emphasize it, it's not a question of either or. It is that by working in something in which you are forced to think about a problem which you have not thought about before, in which you do not know the answer, there is a greater probability that you'll come across unexpected things, or in which curiosity will lead you to something that's unexpected, is higher than if you just do one or the other. So it isn't a question of substituting one for another, it's a question of using a problem to stimulate creativity.